Assalamualaikum and hi. So today we are from group 4 and today we're going to present about our assignment is the production of hydrochloric acid. So first thing first, let's meet the groups. So the first one will be Danish with the matrix number is 227398. Second one is me myself Akil Muiz 227359. The next one is Saris Alan. Matrix number is 226594, and the last one will be Wafa Najwa with the matrix number is 2399. So first thing first, let's start with our introductions. So our product, which is hydrogen chloride, synthesized by using a direct synthesis method. Um, from hydrogen gas H2 and chlorine gas. So these exothermic reactions occurs readily when the two gas are mixed in the presence of UV light. So they are usually occurs in a controlled environments so that it ensure its efficiency and its safety.
Alright, so let's go through for the background. So here we have hydrochloric acid. Hydrochloric acid is an essential industrial chemical widely used in various sectors, including chemical processing, metal refining, food production, and water treatment. It can be produced through the direct combination of hydrogen, which is H2, and also chlorine gases, which is Cl2, to form hydrogen chloride gas, which is HCl, which is then absorbed in water to produce aqueous hydrochloric acid. And as for this project, we aim to analyze and optimize the production processes of hydrochloric acid to ensure the 99% purity of hydrogen chloride vapor through optimal reactor design and fit control. And then we will try to achieve 37% concentration of liquid HCl via effective gas absorption and cooling. Evaluate reaction and absorption efficiencies to minimize losses and improve product quality, and study safety and environmental concerns related to handling H2 and Cl2 gas, and also develop energy efficient and scalable solutions for industrial HCl production. Alright, next for the method is in this project we decided to use a process named direct synthesis of hydrogen and chlorine. So hydrochloric acid from this process is made by reacting hydrogen gas with chlorine gas, obviously, since the name is actually direct synthesis of hydrogen and chlorine. This reaction happens quickly and produce a lot of heats because we need to separate the H2 from the water and any other chemicals that we use in these processes. And the hot hydrogen chloride gas is then cooled down in the cooling tower and anything else that we have in this process, because we have a lot of unit in this process. And after that, it is absorbed into water to make hydrochloric acid with a concentration of 37%, which is make it a liquid acid. This method is simple and efficient, but safety is very important because the gases used can be explosive.
Water may seem safe, but it can still hazardous. Hazard: cold water shock, drowning, strong current, or deep water danger. Precaution: always supervise children near water. Don't dive into unknown or shallow water. Don't drink untreated or dirty water. For the treatments, clean the area and treat injuries as needed. Move to fresh air. Provide artificial respiration if necessary. Read, smell, and drink clear water. Methane is a dangerous gas with serious risk. Hazard: extremely flammable and explosive, invisible and odorless, cryogenic burns and frostbite. Precaution: keep away from ignition source. Use in well-ventilated areas, prevent oxygen-deficient environments, monitor air quality. For the treatment, move the person to fresh air immediately, cover with sterile dressing and seek medical help, remove wet or frozen clothing.
Okay, this is a safety briefing on Cl2, or known as chlorine. Now, chlorine is a toxic gas with serious hazards, but proper precautions and quick actions can reduce risks. And now the points will be hazards, precautions, and its treatments. Okay, so mainly chlorine is a very toxic gas. Even small amounts can be fatal if inhaled. And not only that, it is a severe irritant, meaning it can easily burn your eyes, your skins, and even lungs if you catch contact. And also, it's very reactive to water and moisture, which can form corrosive acids. And lastly, it is heavier than air, meaning if, say, a leak were to happen, chlorine will collect in the low areas, creating hidden danger spots. And now, to the precautions, we could always, we could use chlorine gas in ventilated areas and not confined spaces. And don't forget to wear full PPE, such as chemical gloves, goggles, and respirators. We could also store it separately from flammables and ammonia, because it could cause an explosive reaction. And we should also monitor air with gas detectors to prevent unsafe exposure. And in its treatments, if we inhale chlorine gas, or if somebody inhales it, we should move them or into fresh air immediately and seek medical help. If it if it touches or have contact with your eyes or skin, you have to wash it for 15 minutes. And if a gas leaks, you have to evacuate the area and call for help. Only trained responders should handle chlorine spills.
So let's start with my unit first. So I will be presenting about the first unit, which is the heater. So the heater uh, add to increase the temperature of the water itself. So in the stream 1 with the pressure 25 bar from temperature 5 Celsius, um, we increase the temperature of the water to 99 Celsius before it's enter the superheater in the next unit.
Next, we have the superheater section. Here, we are looking at the conversion of saturated liquid water into superheated steam. The operating condition of the superheater is at a high temperature of 710 Celsius and pressure ranges from 3 to 25 bar. As shown in the box, the feed to the superheater is liquid water at 5 Celsius to 49 Celsius with a pressure of 3 to 25 bar, and the product stream is superheated steam at 710 Celsius and the same pressure range. We are using a basis of 10 mol of H2O, which undergoes complete phase change, meaning the number of moles entering and exiting remains the same, but the phase changes from liquid to vapor. At the bottom, we can see a table summarizing the mass and mole flow calculation. The molecular weight of H2O is 80 gram per mole. The molar flow rate is 100 kmol per hour. This gives a mass flow rate of 1018 kg per hour. Since H2O is the only component, both the mole and mass fraction are 1 or 100%. This shows the superheater efficiently converts liquid water into steam without any losses.
So let's go through for the steam methane reaction. So for this unit, we actually ran a process called steam methane reaction. This process is actually use H2 and CH4, which is methane and water, to react so that it will produce CO, which is carbon monoxide, and also H2, which is hydrogen gas. The purpose of this reaction is actually to produce H2. So for the stream 1, we feed in H2O, which is water, and stream 2 we feed in CH4. Then it will react to produce CO and H2. Then the CO, H2, and also the other excess H2O and CH4 will be used for our next process.
The next units I will be talk about the compressor. So the intent of these units are to increase the pressure of the methane from the feedstocks. So as we can see on the stream 1, the pressure are 3 bar and the temperature is 100 Celsius. So we can see the flow rate we set at the basis are 100 and the mass flow rate are equals to 1600 kilogram per hour. So on stream 2, we can see the pressure are increased to 25 bar while the mass flow rate are maintained. As I said earlier, this unit intend to increase the pressure of the methane itself before entering the SMR.
So let's go for our next unit, which is membrane separator unit. So for this membrane separator unit, why do we choose this membrane separator? Because the reason we choose membrane separator unit is to separate the hydrogen gas from any other gases that we have from the stream. So as we know that in the stream we have H2O and CH4, also CO, and the last one will be H2 lah. Okay, so from this separator, it actually has a component that we call as semi-permeable membrane. So for this semi-permeable membrane, it is actually works to separate the most lightest gas in the stream. So as we know that H2 or hydrogen gas is the most lightest gas that we have, so hydrogen gas will be separated from any other gases, and the other gases will be removed from the process.
Assalamualaikum and hi. So today I will be presenting about my unit, that is combustion chamber. So this unit intend to produce HCl from the reaction of H2 and Cl2. So as we can see on the stream 1, the H2 enters the unit with 100 kilomole per hour, and the Cl2 enters the unit on the stream 2 are equivalent to 104 kilomole per hour. So this difference came from the ratio I found on one of my article that I made the readings. So the ratio are about 1.05 H2 are equivalent to 1.15 Cl2 must enters the unit. So from that we get 104.104 kilomole per hour. So on the stream 3 we can see the HCl that produced from the reactions equals to 3608.55 kilogram per hour, and the Cl2 41,856 kilogram per hour, and the H2 equals to 2 kilogram per hour. From that we get the total of mass flow rate equivalent to 4018.96 kilogram per hour. That's all from me.
So let's go for our next unit, which is the cooling tower. So this unit actually added to cooling down the temperature of the stream, so that the outlet stream will be much more cooler than the inlet. And in this unit we don't have a reaction occurred, so that the inlet and outlet will be the same value. And the reason we choose this cooling tower is to cooling down the temperature of the stream, so that the outlet stream will be much more cooler. And why do we need to add this cooling tower is because after this cooling tower we need to uh, connect the stream to the absorption tower. So for the absorption tower, it couldn't work if the temperature of the stream is higher than its optimal temperature. So that's why we choose this cooling tower, so that the absorption tower can work efficiently.
Alright, in this unit, we have an absorption tower which is designed to scrub hydrochloric acid gas from a mixed gas stream by dissolving it in water. The process starts with two inputs, which is stream 1 and stream 2. Stream 1 consists of HCl, H2, Cl2, and HCl. And in stream 2 is mainly just pure water. Inside the tower, the water absorbs 95% of HCl, leaving behind the clean gas, which comes out in stream 3 with just 0.96% of HCl. Now, the HCl rich water exits separately in stream 4 because it works because HCl dissolves easily in water while H2 and Cl2 don't, making this a simple but effective way to purify the gas stream.
This slide shows the process flow and data for our scrubber system. Stream 1 is the inlet gas, mainly HCl, along with small amounts of H2 and Cl2. Stream 2 is the water stream entering the scrubber. Inside the unit, HCl gas is absorbed into the water. As a result, Stream 3, the gas outlet, has a reduced flow rate, showing the HCl and other gas have been partially removed. Stream 4, the liquid outlet, now contains HCl dissolved in water, with HCl making up 37% of the mole fraction. This shows the scrubber effectively remove HCl from the gas stream and transfer it to the liquid phase.